and welcome back to another class of fundamentals of particle and fluid solid processing. So, we were discussing about the fluid solid processing related to filtration. We have discussed the cake filtration in when we have seen the resistance of the cake and resistance including the filter media, these two scenarios, and we have solved two worked out problems to understand the theory. Now, mostly and in fact we have dealt only with the incompressible cake assumption, that the voidage of this deposited cake does not change with pressure, or the specific the resistance becomes or remains same. So, but most of the cases it has been seen that this specific cake resistance increases with applied pressure difference. Now, if we recall these expressions that is shown here, okay, we can see that this specific cake resistance is basically dependent or a function of the bed voidage or the porous medium porosity. Now, the point is that when this initial cake deposition happens and after that this cake thickness increases, so what happens, this particle drag, the fluid that drag that being exerted on the particles, that transmit throughout the bed, that the bulk motion of this fluid that exerts on this particles, that and when it settles, this force basically propagates throughout the bed. So, the particles that are lying exactly on the filter media, okay, that feels a force that is the summation of all the particles that has been deposited on top of this to the upstream surface of the cake deposition layer. So, and this makes the packing more denser, and as the pressure difference changes, so this becomes influenced. Okay. So, this cake porosity changes with the applied pressure. Now, in case of soft particles, their shape and size may change during the deposition or under this pressure, that leads to the decrease in the overall voidage of this cake. And in these cases, the problem, the way that we have solved the earlier problems or that we have handled the earlier problems is not the similar. So, this kind of scenario or this kind of cake, we say that these are the compressible cake because the resistance, the changes with applied pressure. So, how do we deal such system? So, let us say we have a filter medium which is the shaded part. The flow is happening from this right side to the left side. Now, this is happening at a velocity u. We take and let us say this is the thickness of this cake that has been deposited. Okay. So, this is say the upstream surface of the cake, this is the whole length, and if we consider an elemental length say dl, the pressure drop from this upstream of the cake, okay, or since the interface of the bulk liquid and the cake to this point, if this we consider is the del p. Okay. So, now in this case the differential pressure will be dp for this elemental region, and for this case if we assume that the flow is happening in laminar condition, then minus dP by dl is basically the specific resistance multiplied by viscosity and the superficial velocity. Now, this specific resistance we have seen the expression. Now, this RC is a function of pressure. As this pressure increases, the resistance increases because the cake becomes more denser and denser, the voidage is lesser. There is less path to flow for the filtrate. Now, if we consider this scenario that RC is basically the function of this pressure difference that is happening at the upstream of this cake surface to this surface of this elemental area, then we can write that Ps is basically P1 minus P, or minus dPs is basically the dP, which means this expression of minus dP by dl is equals to RC mu u becomes this expression. Now, the point is here, this RC versus PS, this relation is not easy to find. This has to be determined by several laboratory experiments. The relation between this pressure difference and the specific cake resistance. If we have those data set, we can use this expression and we can find out the relevant expression for the time required to filtrate a certain volume V of the filtrate in case of compressible cake. So, the point that you have to remember that in case of compressible flow, this specific resistance is varying with pressure. So, based on this idea, there can be several experiments to perform, and we can find out that what is the relation between this RC and PS that can be used in this expression to find out what is the required time or the volume of the filtrate that can be processed at a certain point of time. Now, we will move on to the several practices that actually happens during this filtration process. That what are the suggested processes or what are the suggested criteria to follow an appropriate filtering condition. The immediate point is the filter medium that we should choose or that is chosen for a certain process. We have to remember that this filter media is basically acting as a support to the filter cake. Now, all the discussions that we are doing or we have till now, the orientation of this filtration we call as the dead end filtration, which means the surface area, if this is our filter surface area, the flow is happening perpendicular to that, the surface that is available. The other way of filtration that we will discuss in the later stage is the cross flow filtration. So, which means if you have this filter media, the flow is happening parallel to the surface of the filter medium. So, in this dead end filtration, this and in crossbed filtration also, we have the filter that actually acts as a support to the filter cake. The initial deposits that basically acts as a true filter medium. So, which means this filter medium has to be strong enough to withstand high throughput of the suspension, as well as the weight of the cake, the impact of the particles, impact of the suspension. It should be resistant to corrosivity, and ideally it should have a insignificant contributions toward the resistance to flow, because it is the initial deposits of the cake which will act as filter. Typical material that are used for this filtering medium is or are the oven materials. Now, the selection of these oven materials largely depend on how easily the cake can be removed from the surface, because remember, in all these cases that we are discussing, we consider that solid particles are the valuable product that are deposited on the surface, and we can easily scrap it out. We can process those solids and we can recover the solids. So, the choice of this filter media in such cases should be such that we can easily take out that cake and wash it. For corrosive liquids, typically the granular material or porous solids are used as the filtering medium, because these oven materials are typically prone to fouling, as well as the corrosivity of the solution or the suspension can harm that filter medium. Now, during this process, we have mentioned this, but let us take a deeper look into this, that when this initial deposition happens, this formation, initial formation of this cake layer is an important phenomenon, because it then dictates that how the filtration rate will be. So, we mentioned that there can be two processes. One is the blocking of the pore of the filter medium, and the other that will sit on the surface. We broadly classified in these two processes, and also it is mentioned, I have mentioned that these two processes sometimes cannot be separated. Now, this blocking of pore depends on the nature of the surface structure of the filter media, its affinity towards the particle or the suspension, and the movement of the particles. These particles in suspensions are moving freely, and it is having the bulk velocity of the fluid. So, to block the pore, it has to be streamlined and targeted towards the pore, which is sometimes very difficult. So, the point is that this initial cake formation process ranges between two extremes. One is the penetration of the pores by the particle, the other is the formation of bridges to prevent this entry of the pore. So, this process basically plays in this two extreme range, sometimes one, sometimes other, and most of the times it is the interplay between these two. Now, the specific resistance of cake, it is typically assumed to be dependent on the amount of deposit, and it works, this assumption works pretty nicely, because after several experiments it has been proved that this specific resistance to the filter cake is actually dependent on the amount of the deposit that is having on the top of the filter medium. But having said that, the influence of pore and particle size distribution is also important, because what can happen that multiple particle can go into a single pore or in only one pore. So, in that case what happens, the resistance increases in stages. That earlier what was happening, that one pore was blocking by one particle, and then the successive particles were filling the other pores. So, the resistances were increasing smoothly. But if there is this pore and the particle size distributions in such a way that the multiple particles can go into one pore, then you can think of preferential deposition of the particles, and in that case you can have a resistance of the cake that increases in steps. But practically some pores will never be completely blocked, and some pores will be half or poorly blocked or partially blocked. So the cake will have lower resistances in those areas of this partially blocked or completely open pores, filter pores. Now, particle concentration in the suspension has significant influence on this cake resistance or the filtration rate. In the overview of the introductions, we have mentioned this, but let us see why that happens. The reason is that when there is the higher concentration of particles, the distance between two particles are very close. Okay. So, in order to streamline these particles towards the pores, to block those pores is difficult. So, what happens? These particles of high concentration evenly distributes over the porous, this filter media, okay, and the blocking of this pores, this tendency goes down. So, that results in the cakes of lower resistances, and quite naturally, since it is not blocking the pores, it is not going into the pores, the interparticle breezes are formed, and that deposits on the surface. It is not going into the pores, that is not in the mode of deep bed filtration. Also, sometimes with the concentrated suspension, what happens? In concentrated suspension, the size ranges are not very wide. There is a narrow size distribution of the particles, which means that these particles, if those are settling rapidly or the sedimentation rate is higher, then that would be the same rate of particle sedimentation, because the size range is narrower. All the particles will try to sediment at a certain or at a similar time, which means there will be rapid build-up of cake if the filter surface is facing upward direction. That means the particles are settling, and it is settling all at a time, approximately at a time. So, there will be a rapid build-up of the particles on this filter surface compared to if that is having a downward phase, because then their particles are sedimenting basically. So, in that case only the smaller particle in that narrower range will come closer to the surface or will sit on the surface, and you have an enhanced rate of filtration in case of downward facing filter, because here the cake thickness is lower. But in case of dilute suspension, the large particles will settle faster. Now we know by Stokes' law the terminal velocity, and if the larger particle sits faster, you can think or you can imagine that the cake will consist of these larger particles which has a larger voidage, and it will create a low resistance cake. So, in case of this dilute suspension, now consider the scenario of downward facing filter surface. Now, in that case what will happen? Fine particles will come closer to the or will sit on this filter surface, will stick to the filter surface. So, there will be preferential deposition of fine particle on the case of downward facing filter surface. So, in this case the cake resistance will be much larger than the upward facing surface. So, the orientation of filter surface or the filter medium in such cases is critical or has to be considered, considering your particle concentration in the suspension or in the slurry. So, during this practice of filtration, these things have to be kept in mind. Now, in order to reduce this cake build up, because now we know this filter cake resistance increases and the filtration rate reduces, which is not desired, and that this happens particularly in case of constant pressure operation. So, there are attempts to reduce this build up, this cake thickness, and that has led to the introduction of moving blades in the equipment near to the filter medium, so that it scraps those cake that is happening or that is depositing after a certain thickness that has been deposited. So, this cake thickness then is restricted to the gap depth between the medium and the blade surface. So, you give a certain depth or certain clearance between the blade and the filter media, and that would be the thickness of the cake that you want it to deposit. So, in such cases, roughly constant rate of filtration can be achieved, and then this cake that is now removed after scrapping retains in the suspension. So, what happens, this with time, since these solids which were depositing as cake is now retained in the suspension, the concentration in the suspension increases with time or in the feed vessel, until a situation appear where there is physical contact between the particles, there is no space to move those particles. Now, that leads to the significant increase in the flow resistance and huge reduction in filtration rate. So, by this way you can have a higher rate of filtration, the overall rate can be higher than the conventional manner, but after a certain point, as it has been mentioned, that the significant increase in this resistance of flow will be seen, and suddenly this filtration rate will be 0. Now, such a way, by delaying this cake deposition of or having the cake deposition of certain thickness, the results are that it creates a compressed resulting cake due to the breakage of particle bridges by the blades of this moving blades. And since these suspensions are having are getting more and more concentrated, okay, and we are having this cake of certain, or let us say a controlled thickness, we can have more drier final cake in such case. It is becoming compressed, as well as, since it is becoming compressed, the filtrate that were there loosely inside the pores is becoming more and more drier. Now, if these blades are of rotating in nature, or means if that is inside the equipment, if there are rotating blades or rotating scrapers. Now, depending on the speed of those blades, cake thickness, different cake thicknesses are achieved, or different types of cakes basically are achieved. For example, when there are low speeds, the cake thickness is limited to the clearance depth, but the depth actually this build-up occurs again when that scrap is gone, and the time interval in between the another blades or that same blade comes after a certain interval to scrap those cake. Now, in that time interval the cake build up can happen, so that means the resistance will vary if that is moving at a low speed. But in case of high speed, there is a little, very little time or lesser time for this build up to happen. It continuously removing the excess cake thickness beyond the depth of this distance between the filter media and the blade. So, in high speed we have actually the constant cake thickness with time, and here we achieve a significantly lesser thickness than the clearance depth also, because once this is rotating at a very high speed, okay, near the blade there are the wakes that are formed in the suspensions, the turbulence, that local turbulence that is formed. So, basically the thickness of the cake is not exactly to the thickness of the gap that has been provided between the blade and the filter media. There is optimization between this force that helps to stick to the surface or the upper surface of the cake and the convective motion of the suspension near the blade. So, in order to reduce this cake deposition, the other way is the cross flow filtration that we have mentioned at the beginning. In cross flow filtration, what happens? The flow is happening parallel to the surface of the filter media. So, how the solids can build up? Now, if you think of the scenario that there was a flat plate and the flow was happening, the flow over flat plate, there was the development of boundary layer where the velocity is very low, it is the viscous effect only. So, which means if that is the only viscous effect is there, the sedimentation of the particles will happen and will form a layer of cake in that boundary layer, and this thickness is very low, which means you can have a constant rate of filtration for a longer time. Such scenario is helpful when there is flocculated slurries and in fact there are shear thinning non-Newtonian liquids that we are handling. The scenarios where dilute solutions containing fine solids, because those fine solids basically block the pores, it goes inside the pores. The examples are like ultrafiltration using membranes during, say, the water purifications. In this case, the cross flow rate is in fact several times higher than the dead end filtration rate, the flow rate. The inflow rate or the feed rate in such cases, to have a certain rate or a fixed rate of filtration, is in order of magnitude difference in the inflow rate of the flow feed. So, we have mentioned there is pretreatment whenever that is required. So, when there is a very dilute slurry and quick settling particles are there, then it is logical, and in fact the pretreatment happens in a thickener to concentrate that solution or the suspension. Then what happens? You can handle a reduced amount of the slurry. If the cake is of larger particles, that we have now know that is desirable. So, in order to make such cake, okay, chemical agents are added or additives are added in the suspension, so that the slurry becomes coagulant. The coagulation can happen, and once that happen, the particles get bigger and bigger, that deposits, it creates a flow resistant cake. Also, if this is happening by precipitation, the reactions, the particle size also can be controlled by temperature, concentration, the pH of the solutions. There are also examples or practice of adding filter aids when the cake becomes impermeable, which means hard to flow inside the cake. Now, such characteristics of the cake is not desirable. It has to be porous in nature, so that the filtration can happen. Now, these filter aids has a basic property that can form a bed of very high voidage. So, it is mixed with the suspension as a pretreatment, and then the whole suspension plus the additive or the filter aids are flown through the membrane. So, it reduces the specific resistance, but the cake thickness increases. It creates a packed bed of higher voidage, but the packed bed height increases. So, there is an optimum amount of additives or filter aids that needs to be added. Now, definitely the economical perspective has to be there, that how much is economic, but at the same time it has to be taken care that if this filter aids are easily separable from the cake or not, because this is the cake that we are collecting and refining as our product, valuable product. So, it has to be easily separable from the cake. This usually results in compressible cake, because as there are high voidages, so if you apply high pressure, this voidage is changing or changes. So, the benefit of adding this filter aids must not be destroyed by high pressure operation. And the bed voidage typically varies between the two extreme of bed voidage created by the filter aid and by the only solids. In this range, this bed voidage varies. Several researchers have shown that by adding this filter aids, the bed voidage can be achieved as high as 0.85. Sometimes the filter medium is pre-coated with this filter aids, so that from the initial deposition itself there is the higher voidage and lesser resistance for the filtration, but the filtration is happening at a constant rate. During the removal, a thin layer of filter aid is also scrapped with the cake at the end of each cycle. These are the practices. And also at the beginning we mentioned that the reduction in filtration time can be achieved by reducing the viscosity of the filtrate when the value of filtrate is not lost by dilution. In such case, we can try to dilute the suspension to reduce its viscosity and have the filtration. But in that case, we have to keep in mind that the value of filtrate is not lost. So, these are typically the filtration process, and of course, after filtration there is the washing process that we have already discussed. In washing process, particularly in case of compressible cake, the channeling phenomena can occur, because you can think the compressible cake is having a nature that changes with pressure. So, during this operation, it will try to flow through a less resistance zone, and once it can find that, then that zone increases with time and with flow, and this is called the channeling, the preferential path for the flow that will happen in such cases. This can be prevented by operating the washing at a lower pressure drop, so that this change does not happen, this change in porosity or the expansion of the bed does not happen. So, these are the practices in filtration pre and post process stuffs. With this, I will conclude today's talk, and in the next class we will see different types of filters and its selection criteria. With this, thank you for your attention.